Assalamu alaikum. Well, students, last time we solved two parts of question 4 of your first exercise. One part of that question was left. Let us solve that question first before we move to the next topic. The question that we were solving was about subtraction of algebraic expressions, and you were told whenever you have to solve a question on subtraction, you will always find the word from there, and then the rule is you have to first write the expression which is after from. Well, the two polynomials of this part, out of the two, let us write the one after from first. So we have question 4 part C. We'll use two brackets for two expressions. And in the first bracket, we'll write the expression which is after from. It is 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square cube. Here we close the first bracket because this is the expression after from. Now it will be followed by minus sign because we have to subtract the two expressions and then begin the second bracket for the second expression to be subtracted. And this expression is 4p square cube 4p square cube minus 3p cube 3p cube plus 5p cube square 5p cube square minus 8p plus 7q minus 10. We close the second bracket also. These two expressions we have to subtract. So we have subtraction sign between the two brackets because we are subtracting. And in the second step, you were told last time, you have to first remove the brackets. And for removing the brackets, the rule given was, if you have outside the bracket plus sign like here, we don't have any sign, it is plus. So all the signs inside will remain same. And if outside the bracket you have minus sign like here, then all the signs inside the bracket will change. Now using this, we'll get 18 as 18, minus 3p will remain as it is, minus 11q plus 5pq. All the signs I am keeping same because outside the bracket I had plus sign, minus 2pq square plus 5p square q. That was first expression. I removed the bracket number 1. Outside it had plus sign, so all the signs I have kept same. Now for second bracket, sign outside being negative, all the signs will change. So 4 will become now minus. It will be minus 4p square q. Then plus 3pq. Minus 5pq square. Plus 8p. Minus 7q. Plus 10. So I removed the second bracket also. I changed the signs here because outside the bracket I had minus sign. Now, having done this, we have to now combine the like terms. There are different pairs of like terms with different variables. We'll first collect them to combine them. Let us first collect them. First of all, we'll collect the constant terms. There are two constant terms, 18 and this last term 10. These are two constant terms without any variable. These are therefore like terms. We'll collect them and write them together, 18 plus 10. This first pair of like terms. Then another pair of like terms we have with variable part p. Again we have two such terms, this 3p and this 8p. These are like terms. We'll collect them and write them together with their proper signs, minus 3p plus 8p. Second pair of like terms. Then another pair of terms with q as variable part. 11q, 7q. We'll have minus 11q, minus 7q. This is another pair of like terms. Followed by another pair of like terms with variable part pq. Two such terms again we have. This 5pq and this 3pq. We'll write them together. Plus 5pq plus 3pq. Then another set of like terms we have with variable part pq square. Two such terms again are there. This 2pq square and this 5pq square. Both have the variable part same, pq square, pq square. These also will collect and write together, minus 2pq square minus 5pq square. It's another set of like terms. And the last one is with variable part p square q. Here we had pq square. Square was on q. Square was not on p. Here we have square on p, not on q. And we have two such terms also, p square q. There is this another p square q term. So the like terms. We have plus 5p square q minus 4p square q. So we collected like terms, different sets of like terms. Constant terms with variable p, with variable q, with pq as variable, with pq square as variable, with p square q as variable. Now these like terms we have to then now combine. And for combination, you were earlier told what is the rule. If the like terms have same sign, you have to add them. If they have different sign, you have to subtract them. And the result always has the sign of the larger number. Out of the two numbers to be combined, the larger one, the sign of the larger one is used. If the larger one is plus, the result will be plus. If the larger one is minus, the result will be minus. Now using that, we find this first set of like terms 18 and 10, they have same sign as this is plus, this also is plus. Therefore, we add them. 18 plus 10 will become 28. And what will be the sign of this 28? Larger out of these is 18, which is plus, so 28 will be plus. And then another thing you were told that while combining, adding or subtracting, you have to add or subtract only the coefficients. Variable part you have to keep same. Like in the second set of like terms, p is the variable part. So therefore this p will remain same. We have to combine only their coefficients. Now find out what are the coefficients in the two terms, like terms of this variable part p. In the first term it is minus 3. Let us write in the rough column this minus 3. P I shall leave because the variable part will remain same. The second like term with variable part p has 8 as coefficient, plus 8. Combine these. Their signs are different. This is negative, this is positive, different signs. So we'll subtract them. We'll get 5. And 5 will have the sign of larger part, plus 5. Result is plus 5. Variable part will remain same. Variable part being p, so it will be plus 5p. Next pair of like terms we have with variable part q. Now same procedure will apply. Variable part will keep same. Q will keep same. We'll write in the rough column first their coefficients. What is the coefficient of the first of these like terms? Minus 11. And the second of the term has minus 7 as coefficient. You have to combine these coefficients. Variable part will remain same. Now what do we find? Here the signs were different, so we subtracted them. We find now the signs are same. You have to add them. 11 and 7 when added will give you 18. And will it be plus 18 or minus 18? Larger out of the two is 11 with minus sign, so it will be minus 18. This is the coefficient. Variable part you have to keep same. Q is the variable part, so it will be minus 18Q therefore. Next pair of like terms is with variable part PQ. Let us combine now these. Let us write their coefficients in the rough column. Leave the variable part because that will remain same. We'll write that later with the result. Coefficients are 5 and 3, both positive. 5 is plus, 3 also is plus. Now they have same sign, so add them, 8 you will get. Plus 8. So it will be plus 8 with variable part same, PQ. Next we have like terms with variable part PQ square. PQ square, PQ square. Now to combine them, use their coefficients. Minus 2 is the coefficient, minus 5 is the coefficient. I did not write with these variable parts because that will remain same. You have to combine only the coefficients. Minus 2 I have written, minus 5 I have written. Now decide, do you have to add them or subtract them? Sign is being same. What will you do? You have to add 7 you will get. And will it be plus 7 or minus 7? Larger number 5 has minus 7 sign, so it will be minus 7 therefore. Minus 7 PQ square. Now finally we have the last pair of like terms with variable part P square Q. Use their coefficients to combine them. One of the coefficients is plus 5, another is minus 4. The result will be 1, plus 1. It is plus 1 P square Q. Variable part will be same. And then you were last time told 1 is understood. 1 we need not write. So we'll simply write it as plus P square Q. That is the answer for this question. With that, our first exercise is complete. We'll begin today second exercise. In the second exercise, you have to learn multiplication of algebraic expressions you have to learn. Now, algebraic expressions here, at this level, we use the term polynomial only for algebraic expressions. So we'll learn how to multiply polynomials. This will include multiplying monomial by monomial, multiplying monomial and binomial, multiplying monomial and trinomial, then multiplying binomial and binomial, binomial and trinomial, all that will be included here. So we'll try to understand how we do that. Well, restriction of like terms and unlike terms we have only in case of addition and subtraction. For combining, if you have to add or subtract, then there is restriction of like terms and unlike terms. You can add or subtract only like terms. If there are unlike terms, you can neither add them nor subtract them. We have seen that as we solved the questions of the previous exercise. Now, there is no such restriction in case of multiplication and division. You can multiply any polynomial by any polynomial, whether those are like terms or unlike terms. You can multiply them. So there is no such restriction. Now, while multiplying, what we need to take care of, therefore, what we have to multiply, how we have to multiply. For example, I shall consider an expression, a monomial, 5x square. We have to multiply it by, suppose, 3x cube. These are the two expressions to be multiplied. Both monomials I have taken presently. Have a look. These are not like terms because their variable parts are not same. The variable part here is x square. Here the variable part is x cube. Had the question been of addition or subtraction, then you would not be able to combine them. Because in case of addition and subtraction, there is restriction of like terms. But we have to multiply here. So for multiplication, there is no such restriction. You can multiply them, even if these are unlike terms. Now how to multiply? Once we have to multiply two expressions, we first multiply their coefficients. We multiply the coefficients. Coefficient of one expression by the coefficient of second expression. Coefficient here is 5, here is 3, will multiply 5 by 3. 5 3s will become 15. Then you have to multiply the variables also. In case of addition and subtraction, you have seen we would add or subtract only the coefficients. Variable part we would keep same. But in multiplication and division, you not only have to multiply or divide coefficients, but variables also. And here on, for multiplying these variables, you have to use the law of multiplication or law of division, whichever exists. In multiplication, if bases are same, base is x, here also the base is x. It is x square, it is x cube, bases are same. Then the law says, in case of multiplication, their powers are added. X will remain same, base will remain same, but powers will be added. X square and x cube, power 2 and power 3 will be added. Now when we multiply the coefficients, we get 15. 5 3s are 15. Coefficients are multiplied. But you have to multiply variables also. So what will you get? X raised to power, their powers will be added. 2 plus 3 will be 5. The product of these therefore is 15x raised to power 5. So remember that unlike addition and subtraction, you have to multiply coefficient by coefficient, variable by variable here. In addition or subtraction, we would keep the variable part same. We would add or subtract only if the terms are like terms. Here, even if the terms are unlike terms. They are like terms or unlike terms. You can multiply them. You can divide them. And then you have to multiply coefficient by coefficient as well as variable by variable. This is the rule that you have to apply here. And then the exercise will begin with multiplication of monomials, monomial by monomial. Then later you will be introduced multiplying monomial and binomial as well as multiplying binomial by binomial. With this information, let us begin the exercise. We have second exercise. You can open your textbook. Exercise 2 is on page number 155. Exercise number is 9.2. Let us begin with question number 1. This question has 5 parts. You have to multiply. We are asked to find the product. Product means multiply. Of the following pairs of monomials. First part. You have to multiply 4 and 7p. The two monomials are separated here by comma. As you have seen in the previous exercise also, where we were asked to add or subtract the expressions. Comma would be put to separate the expressions. This comma separates the two expressions. 4 is the first expression, 7p is the second expression. Both are monomials. 4 is a monomial, just one term. 7p is a monomial, only one term. Now we have to multiply them. We'll replace multiply comma by multiplication here. 4 is multiplied by 7p. Now the rule is, when you multiply, you have to multiply coefficient by coefficient, variable by variable. We find the first expression here, first monomial here, does not have the variable part. It is the constant only. This is the product of the constant and the variable. But this is not the product. It is alone, constant only. But we can express this as the product of a variable and a constant. That was introduced last time also. We can introduce the variable which we have here, p, with power 0. Because anything raised to power 0 means 1. So if we write their p raised to power 0, that will be basically 1, and 1 into 4 will be again 4. So this means therefore you have to multiply 4p raised to power 0 by 7p. So what will you get? You will multiply variable part by variable part, coefficient part by coefficient part. 4 by 7, p raised to power 0 by p. Now when we multiply coefficients, 4 by 7 will get 28. 4 7s are 28. Now multiply variables. Look at this example, the rough column I have taken. It is actually p raised to power 0 here. Multiplied by p raised to power, what is the power of this? Nothing is written, so it will be 1. Now use the law. In multiplication, bases are same, powers are added. What is the first power? 0. Second power is 1. Add 0 and 1. 0 plus 1 will be 1. So it will be p raised to power 1 itself. And whenever the power is 1, like whenever the coefficient is 1, it is understood. Likewise, whenever the coefficient is 1, it is whenever the power is 1, it is understood. Therefore, we need not write that. So the result is 28p. What did we get? How did we get this? We multiplied 4 by 7, coefficient by coefficient. This is the coefficient here. Coefficient of p raised to power 0. I have just now explained. So 4 7s are 28. Then we multiplied that p raised to power 0 by p. Bases being same, we added powers. We got 28p. Second part. We have to multiply minus 4p, first monomial expression, then comma, by 7p, second monomial expression. Now we have to multiply these. We'll first, in the first step, replace comma by multiplication. It will be minus 4p multiplied by 7p. Now the things are simple. We have already read. Same procedure will do. Now we have to multiply monomial by monomial. You have to multiply coefficient by coefficient, variable by variable. In the first monomial expression, minus 4 is the coefficient. In the second expression, monomial expression, 7 is the coefficient. So multiply minus 4 by 7. Here you have to multiply 4 by 7. Both were positive. We got plus sign, plus, plus, plus. Like addition or subtraction, it is not the sign of the larger part. That is done in case of addition or subtraction. Result will have the sign, result has the sign of larger number. In case of multiplication, you have to multiply signs also. Minus plus gives you minus. So therefore it will be minus here. 4 is minus, 7 is plus, so minus plus is minus. Now multiply the coefficient 4 by 7, 4 7s are 28. Therefore this time the coefficient becomes minus 28, minus 4 into 7. We have not so far multiplied the variable part. Coefficients we have multiplied. Now multiply their variable parts. What is the power of this p? Like here it is 1, understood. This also has power 1. Now how we multiply variable parts? We use the law in multiplication. Bases are same, powers are added. 1 plus 1 will be 2. So it will be p raised to power 2 therefore. That is the product of these two monomial expressions. Second part now followed by third part. Part number 3 of question number 1. The two monomial expressions now are minus 4p, the first one, comma. The second one is 7p cube. Have to multiply these. So replace comma by multiplication. This will be minus 4p multiplied by 7p cube. Now let us multiply them. As usual, we'll first multiply the coefficient by coefficient. What is the coefficient of the first monomial expression? Is minus 4. Second is 7. So multiply minus 4 by 7. As we multiply these, you have to first multiply their signs. Minus plus will be minus again like the previous one. Had the rule been of that of addition and subtraction, larger number, sign of larger number, then 7 was positive, larger number, then it should have been positive. But that rule does not apply here. That applies for addition and subtraction. Here you have to multiply signs also. Minus plus gives minus. 4 7s are then 28. Therefore now the coefficient is again minus 28 like second part. Having multiplied coefficients, now let us multiply variable parts. Same basis in the variable part. P, here also P. Power of P here is 1, again 1 here. Powers added, p square it will be. 1 plus 1, 2. But we have another variable here in the variable part, q also. in the second monomial expression. First does not have. Therefore, as we did in the part number 1, variable was missing. We took the power of that as 0 because the variable was missing there. We wrote it q raised to power 0 because it is missing. It is multiplied by q, which does not have any power, means 1 will be the power. Then same rule will be used in multiplication. Bases are same, powers are added. We'll get q raised to power 1. Now we need not write 1, that is understood. Thus it will be p square q again. This was third part. Then part number 4. Same procedure. Part number 4 is 4p cube. It is 4p raised to power 3 this time. First monomial expression, comma. Second monomial expression is minus 3p. You have to multiply these. So what shall we do? We'll again first, in the first step, replace comma by multiplication sign. It will be 4p cube multiplied by minus 3p. Now, earlier you were told wherever there are two signs together, like here multiplication and minus we have to write together, then second sign along with that term is put in the bracket. So minus 3p will be kept in the bracket to separate the two signs. And then same procedure will be used. We have to multiply two monomial expressions. First their coefficients will be multiplied. What is the coefficient here? 4. It is minus 3 here. We'll multiply 4 by minus 3. It is minus 12. Minus plus again minus 4 3s are 12. I did not put the sign of larger number. 4 was then larger. It should have been plus. But the rule says you have to multiply signs also. Plus minus will be minus here. 4 3s are 12. Now multiply their variable parts. Bases are same. Powers are added. You will get p raised to power 3 plus 1, 4. This will be the answer of the fourth part. The last part of this question, part number 5. We now have to multiply two monomial expressions, 4p and 0. This is the monomial expression. This also is the monomial expression. We have to multiply them. So replace comma by multiplication sign. Now what will we get? The rule is multiplication by 0. Whenever 0 is multiplied by anything, the result is 0. Therefore, the result here will be 0. 0 multiplied by anything is 0. This is the answer for fifth part. That completes our question number 1. Now let us begin. Second question. It is similar one. We are asked to find the areas of rectangles with the following pairs of monomials as their lengths and breadths respectively. First part. PQ written within brackets means this is the first part. It is followed by semicolon. After that you will have second part. This is our first rectangle. You have to find area of the rectangle. The dimensions, the lengths and the breadths of the rectangles are given as these two monomials. P monomial is the length of the rectangle. Q is the breadth of the rectangle. So to us here length of rectangle is P and breadth of rectangle is Q. We are asked to find area. Area of rectangle we have to find. You know the formula for area of rectangle. We have to use this in all the parts that will follow. Few of these I will show. Others I will ask you to do them. Now, to find this area, we'll use the formula of area of rectangle. Length multiplied by breadth. Use that. We know area of rectangle is equal to length multiplied by breadth. So therefore, to get the result, get the area of rectangle, we'll use for length P. It is multiplied by. For breadth, we'll write Q. Now just now we have learned how to multiply two monomial expressions. We have to multiply monomial expression P by monomial expression Q. What we do first is we multiply their coefficients. What is the coefficient of the first monomial expression? Nothing is written there. It will be 1. Second monomial expression also coefficient is 1, and the product of 1 and 1 is 1. Again, we understood. It is understood. 1 is understood. We need not write. Even if you write that 1, it will not make any difference. You can write or you may not write. Both things same. Now multiply their variable parts. Their bases are not same. Therefore, we will not add their powers. The product will be therefore P into Q. As I said in the previous case, the first expression has variable P. Second does not have. In that second expression also we can introduce variable P. How? By writing the power of that as 0. Then it will be Q also there. So that second expression is actually P raised to power 0 into Q. Now bases are same, powers are added, will give you P raised to power 0 plus 1. That is 1. And when we use the same procedure in case of Q also, the first monomial expression does not have the variable Q. So we can introduce that. We can write therefore first expression also as P into Q raised to power 0. Q was not there, so I introduced it by writing power 0. Why? Because anything raised to power 0 is 1. When we replace this Q raised to power 0 by 1, it will become again P. What we have here. Now it is multiplied by P raised to power 0 into Q. We multiplied earlier the first part of the variable part with base P. We got power 1. Now use base Q. Powers will be added in multiplication. Again that is 1. So it is Q raised to power 1. The result therefore is P into Q. This is the area of that rectangle which has length as P, breadth as Q. Second part. In the second part, now the lengths and breadths are given. Length is 10 m. Breadth is 5 m. So what shall we do? We'll like the previous part, write these same procedure we have to apply. The length this time is 10 m. So length of rectangle, write 10 m. Breadth of rectangle is 5 n. So we'll write in front of breadth of rectangle 5 n. Area we have to find, so question mark is there. And then we use the formula. Area of rectangle is length into breadth. Use the values of length and breadth. For length we'll write 10 m. It is multiplied by. For breadth we'll write 5 n. Then multiply them. So what will we do? Same rule. We have to multiply coefficient by coefficient, variable part by variable part. When you multiply coefficients, 10 you have to multiply by 5. It will be 10 5s are 50. Now multiply their variable parts. The first variable part contains m. It does not contain n. If you would like to introduce that n, you will have to write n raised to power 0. The second variable part in the second monomial expression has n only. It does not have m. If you want to introduce that m, you can write m raised to power 0. So it will be, I shall show in the rough part, m n raised to power 0 multiplied by n m raised to power 0. Now m will be multiplied by m raised to power 0. N raised to power 0 will be multiplied by n. In case of m, bases are same, powers are added. Here power is 1, here power is 0. Add them, it will be m. So 50 m. Then add n's, n raised to power 0, n raised to power 1. Again, it will be n raised to power 1 means n. The product therefore is 50 mn. This was the second part. One more part I shall show I would like to show the last part. 2 more parts are there, those you will try. Part number 1, 2, 3, 4, 5. I shall now show the length and breadth of the rectangle are 3mn, 4np. So we have length as 3mn. Against length of rectangle, we'll write 3mn. Breadth of rectangle is 4np. Against breadth of rectangle, so write 4np. Area of rectangle you have to find. Again use the same formula. Area of rectangle is length into breadth. Now use for length, value of length 3mn multiplied by. For breadth, use the value 4np. And then multiply them. You have to multiply the coefficient 3 of the first monomial expression by the coefficient 4 of the second monomial expression. 3 4s is 12. Now as we multiply the variable parts, m is not in the second one. So it will be m raised to power 0 there, as I said in the previous 2 parts. And then when we multiply them, it will give you m only. Power 1, power 0. 1 plus 0 will be 1. N appears in both the monomial expressions. When you multiply them, you have to add their powers. The power here is 1. Power here also is 1. So 1 plus 1 will be 2. It will be n raised to power 2 therefore. And the third part of this variable part, p here, is in the second monomial expression. It does not appear in the first monomial expression. Therefore, again, if you want to introduce that, you can write p raised to power 0 in the first monomial expression and then use the rule, bases are same, powers are added, 0 plus 1 will again become 1, so it will again be p. This will be the area of the rectangle, which has length as 3mn, breadth as 4np. We have used the formula area of rectangle is length into breadth. Use this in the other 2 parts also. Solve them and send me on the WhatsApp. I can accordingly see as you send them whether those are correct or not. Next time we shall proceed to the next question of this exercise. With that, we close the day.